Hello everyone, welcome back to my channel. So today we are going to start with another important chapter in physics, and the name of the chapter, as you can already see on the board, is machines. It is not only interesting but also a conceptual chapter and a very important chapter of class 10 physics. And just to make you aware of the fact, the first video of my channel was on this chapter where I have explained all the basics of this particular chapter. Okay, the basics or basic concepts of class 6. Link will be given in the description. I would suggest you to go through that video once so that you can just relate to what I am going to say today and just have a grip on the chapter. So let's proceed. Now before I proceed, I would like to tell you the definition of machine. So a machine is a device by which we can either obtain a gain in speed or overcome a large resistive force or load at same point by applying a small force or effort at a convenient point and in a desired direction. This is what machine actually is. We have so many features on machine. And one more thing is, I will be going to, as per the material which I have prepared, so the order, the definition, it may not match with your book. Okay? So, a few technical terms we have to know about machines. There are a few technical terms which are very important and we will have to know, without which we cannot proceed with the chapter. First is my load. Now, what is load? The resistive or opposing force to be overcome by a machine is called load. Now, why do we use machine? We use machine to overcome a load, right? That means, suppose you need to carry a weight of, suppose 50 kg. For that, you are using a machine. So the machine or the machine that you are using will be overcoming how much amount of force? 50 kgf. Because I am talking about the weight, but you need to lift 50 kg or you need to carry 50 kg. So in that case, you can use a machine, it will ease your work. What is the effort? The force applied on the machine to overcome the load. Now obviously, you will not have the machine carrying the load by itself. You will have to apply the force or you will have to apply the effort so that the load is lifted. Henceforth, the second technical term that we will have to know is effort. Okay? Third technical term is mechanical advantage. Mechanical advantage itself does not have any definition. Mechanical, basically it is nothing but it is the ratio of the above two. Mechanical advantage we can write as MA sometimes. So MA is equal to load by effort. It is a ratio between the load and the effort. Right? Now it does not have any unit. Why? Suppose you have a load of 50 kgs and you have the effort or you are applying the effort, suppose 25 kgs. And make sure both the units are same. It should not be like one you are taking as kgf, another you are taking as gf. One is kilogram force, another is gram force. Both has to be kilogram force. That is, both has to be kgf. Then only you will be able to use this formula and you can apply MA is equal to load by effort, so it's 50 kgf by 25 kgf. 50 kgf by 25 kgf. kgf gets cancelled, 25 2, so MA, that is mechanical advantage, is equal to 2. And we know in ratio, we do not have any unit. Why? Because see, units have got cancelled. Next, we have velocity ratio, a very important thing that you will have to know. What is the velocity ratio? To know the basic formula velocity ratio, it's already written. It is velocity of effort by velocity of load. Velocity ratio VR is velocity of effort by velocity of load. This is the basic formula of velocity ratio. Velocity of effort by velocity of load. Now, we will not use this formula anywhere. Through this, we will derive another formula. We will use that everywhere. Okay? Now, I'm reading out, just listen. If dl and de are the distances moved in the same time t by the load and the effort respectively, then, okay, let me explain you this at first. Suppose this is velocity, right? This is velocity, and what is velocity? Distance by time. It is actually displacement by time. So let us take it as displacement by time or distance by time, whatever you take for the time being. Let the distance moved by the effort be dE and the distance moved by the load be dL. dE and dL. Right? Time remains the same. In time t. So I repeat, velocity ratio, velocity of effort by velocity of load, distance moved by the effort, let it be dE, and the distance moved by the load, let it be dL. Time remains the same in time t. Now we know velocity is equal to distance by time. So instead of velocity of effort and velocity of load, we can write that VR is equal to dE by t. Why? Because dE is the distance moved by the effort and the time taken was t. And we know distance by time is velocity. So we can say dE by t is equal to velocity of effort by dL by t. That is velocity of load. Now applying simple mathematical concept, T and T gets cancelled out. The formula comes to be dE by dL. So everywhere what we are going to use is velocity ratio is equal to dE by dL. Everywhere we are going to use this and not this. Right? Thus, the velocity ratio is also defined as the ratio of displacement of effort to the displacement of load. Next, we have the unit for this. Again, it has no unit. Why? Because it is a ratio. Next is work input. I'm not writing this. A very simple thing, just reading it out. Listen. The work done on the machine by the effort. Work done on the machine by the effort is nothing but the work input. And so work input is equal to work done by the effort. And what is the work output then? Just the reverse. The work done on the machine the work done by the machine on the load is your work output. Henceforth, work output is equal to work done on the load. Now let us come to efficiency. Now efficiency of a machine is the ratio of work done on the load by the machine to the work done by the on the machine by the effort. So efficiency is generally represented by eta. This is my eta. Okay, just like for delta, we write rho. For efficiency, we will use this symbol, that is eta. So efficiency is equal to work output, that is work done on the load by work done by the effort. So efficiency is equal to work output by work input. This is your efficiency. Now, one thing you will have to know, it's a bit confusing, but let us just simplify it up. Efficiency of the machine is the ratio of the work done on the load by the machine to the work done on the machine by the load. This on by, this is a bit confusing. Let us understand it very simply or in a simple manner. See, effort is the force that you are applying on the machine, right? So, effort is the force that is applied on the machine. But what is load? Machine is applying force on the load. Why you are applying effort? Because you need the load to be lifted. So you need to have the work done on the load. That's why you are applying the effort. Right? If you cannot understand, just rewind it 10 seconds back and again listen to what I have said. Imagine and then understand properly. Henceforth, work done on the machine by the effort is the work input. And what is work output then? The work done by the machine on the load. Because you need the work to be done on the load. That's why you are using the machine. That is your work output. Clear? Now this efficiency we cannot leave like this. Because efficiency is expressed in form of a percentage. So simply what we will do, we will multiply into 100 and done. This is the formula of efficiency. Right? Acha. It also does not have any unit because it is also a ratio. And just we are multiplying it with 100, the reason being efficiency or eta is represented in the form of a percentage. Over. Now principle of a machine. Input energy is equal to work done at the effort point. That is effort into displacement of the point of application of effort. This thing I don't think I will have to explain. There it is already explained. And whatever I have said so far, properly, if you have listened to me, you will be able to understand the principle because I have already said it. Okay. Now we have two kinds of machines. Rather, they are not classification of machine. We have classified, or rather, I have classified for you for your better understanding. Don't take it as any classification of machine. Okay. First is ideal machine. Second is actual machine. Now imagine one thing. Suppose you have taken, you all have saw seesaw. Rather, we all have saw seesaw, right? You are applying force on one seat of the seesaw and on the other seat you have kept, suppose, your school bag, quite heavy. Okay, we all know how heavy is our school bag. You are trying to lift it up. Now suppose you are applying a force of 30 Newton. What will you expect? The 30 Newton force is going to be applied on the bag and the bag will go up. I repeat, suppose you have a seesaw. Okay, suppose this is my seesaw. You are applying a force here. You are applying your force here, and here you have your school bag, and you are applying the force. Suppose you have applied the force that is equal to 30 Newton. You have applied the force that is equal to 30 Newton. Okay, what will you expect? This 30 Newton force will be used to lift this bag up, right? That is what should happen. You are applying 30 Newton. 30 Newton is getting applied here. This is what happens in case of an ideal machine. But in actual, this is what we can imagine that it should happen, but actually it does not happen. What happens is the actual case that happens with the actual machine. In real, this 30 Newton force, you are applying 30 Newton, but maybe only maybe only 10 Newton, or suppose, since I am giving you an example, suppose 20 Newton is going. Then where is my 10 Newton going? The first question that will come in our mind, I have applied 30 Newton, but the bag is getting lifted by 20. Where is the 10 getting lost? The 10 is getting lost due to the friction that is applied, applied here. We have the resistive forces, we have so many forces, which is known as the dissipation of energy. Or, in definition, in perspective of a definition, we can say that the force is getting lost in order, or in because we have the frictional force that is getting applied here, right? So we are applying 30 Newton, 20 Newton is going, 10 Newton is getting lost due to dissipation of energy. Done? So part of energy is always destroyed. But in ideal cases, what is happening? We are ignoring that friction. We are ignoring all the forces that can occur or that can be there. We are not taking into account. We are ignoring it. Henceforth, if we are ignoring it, then obviously 30 Newton is going here. That's 30. It is not reducing to 20. So that is in case of an ideal machine. And what we can expect with friction is happening in case of actual machine. Okay. So the three reasons are given here why the energy is getting lost. First, the moving parts in the machines are neither weightless nor they are smooth, so friction is there. The string in it, if we have a string, imagine there is a string, then it is not perfectly elastic, right? And its different parts are not perfectly rigid also. So these are the different reasons because of which the energy is getting lost, or the force that you are applying is getting lost. Now the relationship between efficiency, mechanical advantage and velocity ratio. Relationship I'm writing the short form. Mechanical advantage, velocity ratio and eta, that is efficiency, right? Okay. Now before that we have to assume few things. Let the load BL, effort BE, next time taken BT, right? Now let the displacement of the load, same thing, displacement of the load be dl and the displacement of effort be de. Done? Now work input, we have to find out work input. What is the formula of work? Force into displacement. Force into displacement is by what? So if I have to find out how much work is given as input, we have to take the effort. Sorry, I've scratched it quickly. You have to take the effort. So it's your E into displacement DE, right? It is marked here as 1. What is your work output? It's your load into displacement of the load. Let us take it as 2. Hope this is quite clear to you. Now, what we have saw when we were studying eta, that is efficiency. What we came to know? What is the formula? Formula is work output by work input. Work output by work input, right? And we know what is my work output? L into dl. E, effort into displacement of effort. This is using 1 and 2. Using 1 and 2 we can say this. Now we will just separate it. Let's do load by effort into dl by de. We can do this. Now if you observe very carefully, this part, load by effort, is already standing out to be mechanical advantage. So we have already got mechanical advantage. So MA into dl by dt. So we have got efficiency, we have got mechanical advantage. What we need velocity ratio. Now you all try to remember what I have said. What I have said. Velocity ratio is equal to dE by dl. I have already said you this. That is, velocity ratio is equal to dE by dl. Right? But we have dl by de. What to do? What to do? We will have to do something. Now, we have a solution for this. If we can just make it dE by dl easily, we will be able to find out our velocity ratio. So simply what we will do is, do not apply any sense. Rather, do not apply any concept. Simply apply mathematics. MA into 1 by can we write like this? Just see. I have written it was dl by de. I have written 1 by dE by dl. This is what the change I have done. If you see properly, if I decode this, it will again turn out to be dl by dt. Thing is same, I have written in a different way. We cancel, right? So we have got dE by dl. Now what is our work? Our work is to write MA is equal to, MA into 1 by VR. We have got velocity ratio. Now, my efficiency is equal to this MA into 1 by VR. So we can say MA is equal to theta into VR. And this is the relationship that I have established. This is the way how we should be establishing the relationship between mechanical advantage, velocity ratio and the efficiency. Done? Now the last topic for today is your levers. We have to know it very nicely, and this is the only part of the first exercise from the chapter where we need to know very nicely. What are levers? Levers are nothing but it is a rigid, straight or bent bar which is capable of turning about a fixed point. So, if I talk about lever, it is a rigid, bent or straight bar. I'm just decoding the point, writing. Whatever is given in the definition, I'm just writing in point format. Which is capable of turning about a fixed point. For the timing, we will only know about levers. Okay, we will not go to its class today. In my next video, I will proceed with the classes. Today, only the basic concept of lever I will tell you. how a lever looks like. Now here we are going to deal with the schematic diagram. We are not going to draw a screw bar or a scissor. We are not going to draw. We are just simply going to draw a schematic diagram. So it's a rigid, bent or straight bar. Let us take straight. It's a straight bar capable of turning about a fixed point. Let us draw the fixed point like this. Done? Now let us name one by one. This is the fixed point. This fixed point is known as fulcrum. This fixed point is known as fulcrum. From one side we will apply the effort, and from another side we are going to apply the load. Or rather, from one side load is to be placed and another side effort is going to be applied. So this is my load, this is my effort. Now based on the placement of fulcrum, effort and load, we have the three classes: lever of class 1, lever of class 2 and lever of class 3. Okay. Another thing, the last thing that we will have to know for today is load from the fulcrum, the distance. The distance from the fulcrum to the effort is known as effort arm. EA stands for effort arm. The distance from the load to the fulcrum is known as load arm. LA stands for load arm. Okay, and load by effort was my mechanical advantage. Load by effort was my mechanical advantage, right? This was with respect to load and effort. Another formula is there of mechanical advantage, which is with respect to effort arm and load arm. Very simple. Mechanical advantage is equal to effort arm by load arm. This is another formula. This is also we are going to use in many places. So mechanical advantage is equal to load by effort, that is equal to effort arm by load arm. Numericals can be there where effort arm is given, load arm is given and your load is given. You are asked to find out the effort. So you will find out effort arm by load arm, you will find your mechanical advantage. Now we know mechanical advantage is also equal to load by effort. Load is known to you, mechanical advantage is known to you. You can easily find out effort by simple linear equation. Okay, so this was all for today. Hope you have liked my video. If you like, please press the like button, subscribe and share it. Also press the bell icon. And in my next video, we are going to proceed with further important part of this chapter. And finally, when I complete with this exercise, I will do few numericals and then proceed with quiz. Okay? So till then, bye.